Um, Hello everyone. I hope you all are having an amazing day. So we will actually work on a EDA project that is on our Uber um, ride-sharing dataset. And let me show you. And I actually created a GitHub repo, and in this GitHub repo you will get everything to know on how to get started with the project. I also linked the dataset, so you can go to the dataset and download this zip file, so you will get all the dataset. And the notebook file is also provided in the GitHub repo, and I will post the GitHub repo in the description of my YouTube video. So let's get started. So at the very first, we will actually work using the Uber raw data January to June 15 sample. Okay, so all in all, the data actually contains more than 15 million points or 15 million rows. But to start, we will actually use a fraction of the data. That will be around 1 million approximate data points. Okay. So let's get started. So at first, we will import our necessary packages. So we're importing Pandas, NumPy, Seaborn, and Matplotlib. So we will actually import those, and then we will import another package that is called OS. So this OS package actually enables us to get our dataset from our specific location in our computer. Okay. Um, it will not make sense at the moment, but at the end of our project, you will see how we can combine all the dataset at once. Like we actually have like multiple datasets for different months, you see. So what we will do, we will use OS package to append together all the dataset. Okay, all the necessary datasets. So we will see it. Okay, so using OS package, what we are doing now, we are actually listing all the available data, CSV data in our directory. And what I have, so I am actually in my EDA project one folder. So this is my environment folder. And in this environment folder, I have another folder that is called datasets. Okay. And in the datasets, I have all my CSV data. So in the list, using the OS library and using the list directory function, what I'm doing, I'm actually saying him that go inside the datasets folder and list all the files available there. And for that, we will have to use raw strings. So raw strings is basically just putting the R in front of the, in front of the directory. So after doing this, we get all our necessary data names and everything. And similarly, what we will do, we will actually work using this data. So this is what I'm reading here. Okay. So the data actually has around a million rows, and it actually has 4 columns. Okay. And we can actually check the data. So if we just do over 15.head, so we can see that there is something called dispatching base num, and then the pickup date, affiliated base num, and then location ID. Okay, so this base num is actually the vehicle a person using for the Uber ride sharing. So the vehicle's ID is something like that, and location ID is actually the location, specific location's ID. Okay. And pickup date is the most important column in our data. So using this data, we will more or less try to answer like how many pickups happened in a specific date or month or hours. And we will also try to answer some question like how, how was the rush hours. How was the rush hours in our data, in the rush hours, how the pickup, how the pickup actually ups and down, something like that. So as we move forward, we will understand it very properly. So the very first step in our EDA project is to check if the data columns are properly set. So we will test it. So we will just use the type function, and it's actually a data frame, so it's fine. So at first we will check if our data frame has a duplicated value or not. So for that, we are actually using the duplicated, and we're using sum. So duplicated actually returns you the true or false, and if you sum the true or false, then we will get the total number of duplicated rows. So let's see. So we see that around 54 rows are duplicated in our data, and we can easily, drop the duplicates, because we actually do not need the duplicates, or there is no missing information. So we dropped the duplicate or deleted the duplicate rows, and after that we're actually checking it again. So now we see there is 0 duplicate rows remaining, and here is the shape again. And now we will check the data types. So we see that the dispatching base number is an object, pickup date is an object, affiliated base number is an object, location ID is integer. So the pickup date should not be an object, it should be like in a date time format, because you see it's actually date time, so it should not be object or string. So we will have to properly map it to its proper data type. So before doing that, we will actually check if there is any null values in our data. So we see that there is a null values, especially in the affiliated base num column. There is around 1116 null values in our this column. So okay, we will take care of it later. So at first, let's change my pickup data to its correctly data type. So this is how it looks, and if we check the type, it's a string. So now how we can change its data type to its appropriate data type? We can use Pandas library and a toDateTime function to map it to its appropriate data type, and we're actually overwriting it itself. So let's run it. Now if we check, you see it's showing the datetime format, that is M8NS, and if you see the row, we can see it's in timestamp. We have the date, and we also have the time. And if we check the type, it will show us Pandas timestamp data type. So this means it's correct. And in the data types, we can see it's correctly what is it called, replaced, or correctly mapped. Now let's answer a question, that is which month have maximum over pickups in New York City? So we know, so we see that we do not have the month column. We do not have the month column in our data, but we can actually create the month column in our data by using the pickup date. Okay, so and this kind of thing is actually called feature engineering. We are creating features or columns. So let's create the month, that is month column. And what will be the month column? It will be we will just separate the month name from our pickup date. Okay, so how we are doing it? We are actually using the dt package. Okay, I think it's included with the pandas package, and we are also using the month name function to do the work. So just let us just do it. And now if we check the head, so you see we actually got the associated month with our date. And now what we can do, we can use the month thing and generate a bar chart. Okay, so this is a bar chart, and this bar chart showing like the number of pickups. Okay, and we can see that the number of pickups is the highest for the month June, and it's the lowest for the month of January, something like that. Okay, and so we can actually say that June seems to have a max Uber pickups. Okay, and we can also see this insight into more breakdown way. So for that, what we will do, we will just separate the date time column into other columns. Like we can separate it to weekdays, days, hour, and minute. Okay, so similarly we are using a day name, and then for the day, or the day value, 1 2 3 4 5 6, so we are using day. For the hour value, we are using hour, and for the minute values, we are using minute. If we run it and if we check the head, so you see we got the associated values, associated weekday values, day values, hour values, and minute values. Okay. Now what we can do, we can actually do cross tab and find out the number of pickups. The number of pickups. Okay, let's try. So we see that in the month April, Friday has the most pickup. No. In the month April, the Thursday has the most pickup. Tuesday has, I think, the least. No, Monday has the least. That is around 1833 pickups. Okay, so we get the pickup distribution throughout the week. So we actually calculated or created this kind of pivot tables. Okay. Yeah, and what you can do, like an exercise, what you can do, you can try to sort them and try to sort these months. Okay, so this could be your exercise, like sorting the weekdays as Saturday, Sunday, Monday up to Friday, and the month will start from January to February to June. Okay, because right now it's actually in alphabetical order, A and then F and then G's. Okay, so what you can do, you can just fix the sorting thing. So this could be your exercise. And using this pivot table, I can actually plot a bar and show it in and visualize the above information. So we can see that the weekday distribution for each month. Okay, we can see the weekday distribution for each month here. Okay, and what kind of actually insight we can have from this thing? So we can say that on Saturday and Friday, we are getting more Uber pickup in each month. It seems that New Yorkers used to go for shopping malls, fun activities a lot on these days. So let's check on Friday and Saturday. So you see that on Fridays, all the numbers are quite above 2,200, something like that. And in the Saturday, it is also the same. It's above 200 and 200. Sorry, 2,200 is something like that. The Thursday also have good, but as you can see, the Saturday and Friday are the most, the most pickup days. Okay, I mean, in those days, the pickup has been requested the most. Okay, and as this data is from the New York area of United States, so we are actually seeing the New Yorkers. Okay, now let's find out the hourly rush in New York City on all days. Okay, so for that, what we are doing, we are actually creating another pivot table, but in a different method. We are using group by function now, and previously we actually used the cross step function. Okay, so we will now create another pivot table using weekday and hour to find out the number of pickups during number of pickups for each weekday and for each hours. Okay, so let's run it. Okay, so we see that for Friday and at hour 0, so at hour 0 actually means like 12 a.m. Okay, like 12 a.m. when the new day starts. So at 12 a.m. the number of pickup requested was 581, and then similarly at hour 1 it was 333, at hour 2 it was so something like that. Okay, so using actually table, we are actually not able to see the real picture instantly. So what we will do, we will try to create a point chart or a scatter plot using our Matplotlib libraries or and SNS Seaborn library. So let's see. So we're using the above table, so we can actually check the distribution of pickup requested for each week of the day and for each hour. Okay, and we can see that the Saturday, that is this green line, and the Sunday, that is the red line. So Saturday and Sunday actually have the similar distribution of pickup requested. Okay, um, yeah, they actually have similar distribution up until 16th hour. So from 16th hour on Sunday, On Sunday, the pickup requested uh, actually drops, but for Saturday, the pickup requested actually grows. Okay, so it might be because Sunday people go to rest early because they have work tomorrow on Monday. Okay. So this is how you can actually check the user pattern or user behavior um, using this data. So here I actually wrote a summary from here. In the evening, Saturday pickups continue to increase throughout the evening, but Sunday pickups take a downward turn after evening. We can see that they are the weekdays that has the most demand during the late evening is Friday and Saturday, which is expected. But what strikes me is that Thursday nights also exhibit similar trends as Friday and Saturday nights. It seems like New Yorkers are starting their weekends on Thursday nights. Yeah. So in Bangladesh, we actually call it Pavitra Brihaspatibar Raat. So yeah. So now let's answer another question, that is, which base number has most number of active vehicles? Okay. So which ID number actually has like associated active vehicles, most active vehicles? So for that, we're actually affiliated. So we will actually use the affiliated base num. Um, Oh, I'm sorry. We actually cannot use this data to answer this question. And for that, we will use another data. We will use this data, the FOIL data. Okay, so let me just read it and let me just check the shape. So this FOIL data actually has very less information, but it's actually like a dimension table. So let's check. So this data actually has like the base number and the number of active vehicles, um, number of active vehicles under this base number, or you can say it's an ID number, and the number of trips actually made under this ID number, and I think the day it got registered. Okay, so now we can visualize this data, and I will try to use a different type of visualization library. So I will show you how can we generate visualization using Plotly. So in order to set up Plotly, we'll have to install three different libraries or packages. First one is Chart Studio, second one is Plotly, and third one is this thing. Okay, so what we'll have to do, you will have to just go there and then go to terminal, and you will have to just copy and paste one after another. Okay, so after installing, you can actually import all these files, and if you properly or correctly import this, then you're good to go. And now we are actually let me just import all those things, and we are actually setting up the connection with the Plotly. And let's check the column names again, and we will actually create a box plot using the box plot for active vehicles, and we want to check active vehicles for for different base numbers. Okay, so I think there are around 6 base numbers, so let's just check it quickly. Over foil and then dispatching base number dot value counts. So there are around 1, 2, 3, 4, 5, 6. So there is actually 6 different base numbers. Okay, so yeah, let's check how the active vehicles are distributed for each base numbers. So this is actually a Plotly generated box plot, and the good thing about the Plotly generated box plot is that it's actually interactive. So when you are hovering on the on the thing, so you can see the information associated with it. So we see that the base number, that is B02764, its maximum active vehicles are 4,395. Its median active vehicles are 3,734, and its minimum active numbers are 2,862. Oh, sorry, its minimum is 1,619. It is that value, this value. Okay, this is the minimum one, and this is actually considered as an outlier here. Similarly for all others. So it's actually just a different way of visualizing your data, and Plotly actually provides you the interactiveness. Okay, and you can also zoom in. You can actually zoom in using the plus button and minus button. Okay, okay. So that's it. And we can also see another chart, violin chart, that will give us the same information. So let's try violin chart. So it's actually basically the same thing, but in a violin lookalike. Okay. Now, what we will do, we will actually append together all the similar data sets. Okay. And for that, at first, let's check the files. So we have all the files here. So these are the files. So what we will do, we will actually remove the sample.csv from our files. Okay, because we already used it. We'll remove the sample .csv and we will try to append together all the data. Okay, because it's just a sample data. So we will remove it. No, I will not remove this. Yeah, remove sample. Okay. And now if we check again, so it is not available here, as you can see. So we have January, June, and the all other things. And now at first we will create a blank data frame, and then we will loop together. We will use loop to read each data files, and after that we will use the concat function to append all the data files one after another. Okay, so let's try. So as you know, it's actually a lot of data and it will actually take some time. So it took around 8.1 seconds. So let's try to check the shape. So wow, it's actually a big data set. It's around 18 million, I guess, or no, it's around, yeah, 18 million data points and 8 columns. Okay. So now let's check if we have a duplicated value in our final data set. Yeah, so we have around 980. Okay, 980,000 duplicated value. But if we and we can easily actually remove those duplicate or drop those duplicates. And when we are using the drop duplicates method and we use the in place equals to true, so it will automatically just replace the original data, replace the main data. So let's try it. Okay, now let's check the shape again. So that data rows actually came down to 17 million. And let's check the data. So the data actually has date, time, latitude, longitude, the base numbers, and then some additional columns, dispatching base number, pickup date, affiliated base number, and location ID and whatnot, all those data. Okay, so basically we will have around five base numbers. Okay. Okay. So now we will answer some questions based on locations. At what locations of New York City we are getting rush? So what we can do, we can actually create another table based on latitude and longitude. Okay. We are using group by function here. And let's check. And we are using size, so it will actually calculate the frequency. Okay, so it's like in that specific um, area, in that specific place, latitude and longitude, in that specific place, how many pickup actually happened. So if we use size, then we can get the answer. So in that specific area or place, um, only one pickup happened, something like that. Okay, and now we will actually visualize this what location we are getting rush using what is it called? We're using a heat map. Okay, and for heat map, we will be needing a new library that is called Folium library. Okay, so we will install the Folium library at first, and then we will import it. And at first, we will just create the base map. And you can check the base map here. So if you just use folium.map, then it will create this base map. Okay, this whole world map. After that, we will add a new what is called a new function that is called heatmap from the Folium library. And now what we can do, we can just use heatmap, and the heatmap actually takes a table. Okay, it does not take any specific column, so it takes the whole table, and we will actually provide it the table, because the table has all the necessary information, the area and the specific pickup, number of pickup happened in that area. And we'll use the add to function to show the heat map inside our base map. Okay, it did the work. Now if we check the base map, now if we check that base map, you see something generated here. So let's zoom in. Okay, so you see, so heat map means the hot areas are actually like in those areas more pickup actually happened compared to the green and the blue areas. So actually explained it in the below text section. We can see a number of hotspots here. Midtown Manhattan is clearly a huge bright spot, and these are made from Midtown to Lower Manhattan, followed by Upper Manhattan and the heights of Brooklyn. So these are just the name of the rides actually took place in those areas, like the most common rides. So you see it's something, all those things. Okay, so how heatmap actually helps? So heatmap actually gives us a relative what is it called, a relative idea about the activities happening in our data, and especially in our like ride sharing or pickup data. The heat map is actually very important because it gives us a quick information about like where the activities are most happening in our map. Now let's examine the rush on hour and weekdays. Okay, so we will do the similar thing we actually did a while ago. We will actually segment the weekdays in different hours. Final columns. Let's check our data. So we see that the date time is actually properly not properly not properly mapped. So we will actually do the mapping thing again. So it will take a bit of time because now the data is actually a lot bigger than before. So here you can see, now we will extract the day information and hour information from our original date time. And now if you check our data, so we see that the day information and the hour information. Okay, now let's create our pivot table. So now we can see, so as we have used the unstack, so it is actually showing us like the unstack actually does the aggregation uh, based on columns. Okay, so this is what unstack does. So we can see the number of days, that is 31, and the number of row and the number of hours. So hours starts from 0 to 23, in total 24 hours. Okay, and similarly, you can style the pivot table. So here, so the gradients actually shows the most activities. Okay, so like for the hour 0, the more vibrant colors or the more deep colors actually shows the maximum values, okay, the higher values. So it's like if you consider the hour 14, you see 8200 has more deeper values because it has higher scores, okay. So as we actually have generated the pivot table in a nicer way, so let's actually explain what this distribution actually showing. So we see that the busiest hours, so the heat map shows the highest concentration of pickups occurring in the evening hours, particularly between 6 p.m. to 9 p.m. This is consistent across most days of a month. The busiest days are the middle of the month, that is month number 10 to 20. So if we see the 10 to 20 are always very much hooked. And then the least busy hours are the early morning hours, around midnight to 5 a.m. That is of course um, common sense, pretty much common. And daytime pickups, there is a noticeable increase in pickups starting around 7 a.m. and continuing throughout the day, likely reflecting morning and commutes and daytime activities. Okay, so it's saying that shutter port থেকে or after 7, the pickups actually increases uh, drastically. So yeah, so that's it. That is for our EDA project. And to be very honest, you can actually create or generate more insights out of this data. But the important takeaway is how we can actually use just the pickup date and create um, so many interesting insights using our data set and everything. So I hope you learned something from this project, and I'll try to create more relevant EDA projects and share it with you all. Thank you very much.